All right. Okay, so what are we doing? Should I give you a second to do number one? Okay, go ahead. Do the first one. Remember, we want to have extra time to do the hard ones, so the easy ones, crank through.
What are you guys doing out there? Stop right there.
All right, you done?
Yes.
What'd you circle? Okay, everyone circled 27. What are the pieces you need? Who's that? Up. Who's this? ADJ. Do I need hypotenuse? No. So that means right now at the very tippy top of your paper, write your SOHCAHTOA from memory. Now you can look at it every single time, right? SOHCAHTOA. And it's better if you have it in the fraction form, right? Okay, so which trig ratio are we using? Tangent. So tangent of what? 27. I broke my pen. 27 equals what? Up over adjacent. Okay, then what do we do next? You put this in your calculator, right? So do we use the second button? No, only if we're looking for an angle, which we are not because we have the angle. Tangent of 27, give me 4 digits. What do we got? 0.5. Give me 5 what?
0, 9,
What? 5, okay. Equals x over 15. Okay. Good so far? Remember, do 4 digits within your work. At your final answer, we'll just round everything to the hundredths place. Because I think that's what it says on your test. It says round all answers to the hundredths place. But that means when you're all done. Okay, then what do we do? Put it over 1, crisscross multiply. That times that gives you x. The other side, that times that. Get an answer and round to the hundredths place. 7.65, 64, 65. I'm hearing a 5 and a 4. 4. What's the next number? 2. So no shoving. Okay, so remember, do your final answer, round it to the hundredths place. And then see if it makes sense. Put it over here, 7.64. Look at your triangle. We have a side up here that's 15 long. Is it okay to have a side that's 7 long? Sure. That does not seem outrageous. If you have a weird decimal or super big number, it probably means you hit the second button when you shouldn't have, or you were supposed to hit the second button and you didn't. Okay, this is super quick. Read what it says. You can do this in 2 minutes. Go.
Yes.
Okay, which angle did you circle on this one? J. Why J? Because it said so. It said measure of angle J. So you should have circled J. So that makes the 14 what? Up. What's the 16? Hypotenuse. And you can call him a variable if you like. What variable do you like? Theta. Okay. So you are going to, if you're doing opposite and hypotenuse, what trig ratio are you using? Sine. So you're going to write sine what? Of theta, or whatever variable you chose, equals what? Up over hypotenuse, so 14 over 16. Do set it up like that and have that in a paper. Don't just put like an answer and don't show work, right? Now, for this one, what do we have to do for this one? Will we be cross multiplying? No, because this is, we're looking for an angle. So what buttons do we hit? Second. And then sine. And then 14 divided by 16. And we're going to do, to the hundredths place. So what do we got? 60 degrees. And that's fine. This is a 61.04 degree angle. That seems doable inside a triangle because this is a 90. And so that could be like a 30. So it seems like it makes sense. Nothing outrageous. All right. Next one. You need to look at the bottom of your pink foldable. So look at the foldable for your sine, cosine, tangent. Is everyone looking at the bottom of the front? Did you just read it? It's hard to read while you're talking. Okay, tell me what the bottom of it says. What did you put in a box or highlight? The very bottom of your pink foldable. Sine A equals cosine B. Did you write anything else?
Not really.
Not really?
Or sine B.
What else did you put?
Sine B equals cosine.
It could be backwards. Sine B is cosine A, right? Hopefully you put a little note to never use the right angle somewhere on your paper. Never use the right angle. Never, ever, 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 ever. Don't use it. Okay, so this is basically a memorizing thing. Kind of like when you are going to take government and you're going to have to take a government OST and they're going to just flat out ask you, what's the Second Amendment say? You literally just have to memorize that, right? So you can do the exact same thing with this. It's actually kind of easy. If you look at what this looks like, you have a sine and a cosine. It's always sine and cosine, never tangent. Got it? So you see how they're different? Opposite day. One, if it says sine here, then write cosine there. If it says cosine there, write sine there. Simple as that. And then it has A and B. So you're doing the switchy, right? Opposite day twice. So if I started off by saying cosine of A, what would you say it equals? Do switchy. Sine B, right? You just never use this is all if you had a triangle that looked like this, where this was A and B, right? Because we would never be able to use the right angle, okay? That's what it says in your pink foldable. Okay, so let's apply this to this problem right here. So we have to look at this picture first, because which angle are we not allowed to use? The right angle. So cross him out in your head and don't answer him with anything. Got it? Okay, so go ahead and answer these two as you think they should be answered. Super easy. Switchy. What do you think, sine C? What did you write on the first line? Switchy, cosine, switchy, B, because we're not allowed to use A. Remember, these could be any letters. It could be a P, Q, R, an F, J, H. It doesn't even matter, right? Just look at it and cross out the right angle. What's this guy? Switchy, sine, switchy, B. Easy? You just got to memorize. Something you could choose to memorize or no. But I think that that's easier than doing one of these other problems, right? And on the OST, almost all the problems are worth the same points, even if they take you 5 minutes or 30 seconds, like that one. All right. So this is takes you to the B level. B level is when you have to read it and make the picture first, and then do the same old sine, cosine, tangent like you have there. Okay, so let's read the story and let's think about what this picture looks like. You are flying a kite. You are flying a kite with 20 feet of string extended. The angle of elevation from the spool of string, where's the spool of string at when you're flying a kite? In your hand. Where's the kite? Up in the air. Where are you? Standing on the ground. Nope. How far off the ground is the kite? So how do you measure the height of something? From where to where? The ground to the kite, right? And you always measure straight up in the air, right? You don't measure crooked. If I ask you what my height is, I'm going to put a measuring tape at the floor and go straight up 90 degrees to the top of my head. I will never go from over there stretched up to my head and say I'm that tall. That doesn't even make sense, right? So height has to be 90 degrees from the ground, wherever you're measuring. Okay, so let's draw a picture. Let's start with the ground. Okay, keep your hands to yourself. Okay, here's the ground. I made it green. Where would you like me to stand with my kite?
In the air.
On the left or the right? On the right? Okay, here I am. There I am. Where is my kite? In the air. Straight above me? Is that how a kite flies? No. Here's my kite. The drawing should not be super long. Just think about what it says. You are flying a kite with the 20 feet of string extended. Where does the string go? From my hand to the kite. That is my string. How long is that? 20 feet. Okay, so the angle of elevation from the spool of the string to the kite is 67. Let's do the ending part. We'll do that part last. How far off the ground is the kite if you hold the spool 5 feet off the ground? So let's talk about, where is the spool? In my hand, right here. How high off the ground is that? 5. So from there to there, we got a 5-foot gap, right? So really my triangle is starting 5 feet up in the air, right? And I measure my height where? From the ground straight up to my kite. So this is going to be my orange one is going to be my height, right? Now here's the deal. This is 5 down here, right? But I can figure out right now this piece right here, this red piece. If I figure out that piece, I could just add 5 to it and I would know how high my kite is, correct? That makes sense what my picture looks like? Okay, we have one more number. It says the angle of elevation from the spool of string to the kite is 67 degrees. So where does that 67 go? Over here by the spool, right? So this little angle here is 67 degrees. So do you see my right triangle in there now? Okay, so the right triangle I'm going to deal with is this yellow guy in here, right? So I could circle my angle, 67, label my stuff. I don't really care about the 5 right now because I can get this piece and then just add 5 to it to get the total height, right? Okay, so which angle are we circling? 67. Okay, so which pieces do we need? Opposite, hypotenuse, adjacent, who's what? Opposite is go straight across from the angle you circled. He's up. Okay. And I'm going to need the hypotenuse. That's 20, right? What variable would you like to call this up? X? Okay. He is X. Okay, so I'm going to be using hypotenuse and opposite. So go ahead, set that up. What do you think for a hypotenuse and opposite? So you say sine? Sine what? Sine 67 equals opposite x over 20. Do you guys agree?
Yeah.
Is that how you set up? Okay, then what are you going to do? You're going to put sine of 67 in your calculator and get your, go out 4 digits. Are we going to be doing second sine? We are not looking for an angle. We already have the angle, 67. 0 point equals x over 20. Is that what you guys got? Then what? Put that over 1. Go ahead. Put over 1. Crisscross multiply. You solve. I'm not going to solve. I'm going to give you back your practice work from yesterday. Put it in my slide. Your notes are beautiful. Okay, you crisscross, what'd you get? Round me to the hundredth place. X equals what? 18.41. Okay, so that is this little piece right here, 18.41. But that is not how high the kite is, because why? You got to add 5 to it. Because the kite, you go from the ground up to the kite. So that's 5 feet plus 18.41. So we got the 5 plus the 18.41. And that gives me 23.41 feet up in the air. Question? You okay? Yeah? Okay. I think the next picture is easier. This one was kind of confusing because you're holding the spool 5 feet above the ground. Now remember, if you find a kite and the rope, the string is near the ground, then you don't need to have your triangle up in the air. Maybe you're flying it and just sitting down on the ground, holding it, stepping on a string, something. Okay, go ahead and draw this picture. Now I need you to read this a couple times as you're drawing it, so you make sure you use all the words. Now you notice when I read these problems, I literally say the words over and over. I say, on the wall. So that make sure, and so that's what you should be doing when you read them. Emphasize the important things. So draw your picture and label your stuff.
Now you're wild. You got even a big small big. Yeah.
Leave the door open a little bit. Okay, so your picture should, you have a ladder that's leaning against a wall. First of all, you have the earth, correct? You have a wall. That's my wall. I have a ladder leaning up against it. I could be leaning on this side or that side. It doesn't really matter. What color would you like our ladder to be? Purple. Purple ladder. So this is my ladder. Okay, so this is what my picture looks like. Yes? Okay, it says a ladder leans against a brick wall. Doing it. The foot of the ladder, that my ladder's doing it. The foot of the ladder is 6 feet from the wall. Where is the foot of the ladder? At the bottom of the ladder. So right here. The foot of the ladder to where? Foot of the ladder is 6 feet from the wall. Which way am I going? Over here to the wall. So that means that, ooh, look, my pen just did weird stuff. This is 6 feet right here. Yep. Okay, let's read the next part. It says the ladder reaches a height of 15 feet on the wall. Where do I need to be? On the wall. What color is my wall? Is that grayish bluish, right? So I need to be on this wall. That is how far? 15 feet. 15 feet. Oopsie, I better write this better. 15 feet is over here. Now, sometimes you guys read quick and you're like, the ladder reaches a height of 15 feet, and you just go straight to your ladder and put a 15 on it. Be careful of the words, right? Okay, so are you labeled right? It says, to the nearest degree, you want the angle the ladder makes with the wall. So where do the ladder and the wall meet? Up there. You see it? Right here is the angle that we want, correct? That's where the ladder and the wall meet. So let's call that a variable. What would you like to call him? A. So he's going to be angle A. Okay, so I already have my circled angle, correct? So what am I going to be using? Opposite, hypotenuse, adjacent, who's who? Opposite is who? The one on the bottom. And do I need it? Nope, I'm not using hypotenuse. Adjacent's over here, right? So I'm going to be using opposite and adjacent. Go ahead, set him up. He's a tan. You guys agree? Tan. Tan. Tan what? Tan A equals, I'm hearing 6 over 15. Is that opposite over adjacent? Okay. Tan A is 6 over 15. Now what? Why do I have to hit second? I'm looking for an angle. So you hit seconds. Tan 6 divided by 15. Do I have to do any crisscross multiplying on this one? No. Remember, the angles are the easy ones. Bless you. So give me an angle measure. Arthur, did you put it in already? Give me an angle measure rounded to the nearest hundredth. You got it? Huh? 21 point what? Point what? 48? 80.
I know when you get old, your ears start tweaking.
I know. Ah, shoot. So old. Okay, and this is degrees. And we could definitely have a 21.8 degree angle. That's fine inside a triangle, right? Beep, beep, beep. All right. So this one, we're going to start off. This one looks complicated, but it's not. It looks complicated, but it's not. Now, we're going to use some of the stuff that we already thought about. The sine of this equals the cosine of that. But we got to start off because they don't give us any really numbers in our picture. So the first thing they're asking for is angle C. So if we want to find the measure of angle C, let's look up here because they give us some information about C. See how they give us cosine C equals that, right? Now, if you have cosine of C equals something, I can actually get this angle measure, can't I? Can I get this angle? You all know how to find an angle. What do I have to do? To find an angle, you do second. Hit the second button. So, you're going to hit second. Ugh.
Miss Casper, you know what? I just have to make it happen.
What the heck?
Look it. It's broken.
Happen.
It's because you different.
Second cosine. Okay, you can put this right in. Put that right in. Second cosine 0.2071. These ones are easy problems if you just know how to do them. Second cosine and that jump equals. You got the angle measure. What is it? So the measure of angle C is 78.04.
04.
So 05? Okay.
God, bro. Like, it's dead the same thing.
It's a little bit different, and they might mark wrong on OST. So let's try to be careful, because you know how picky they are. Okay, let's go back to our picture now, because we know that what this angle is. This angle measure, put that in there, 87.05 degrees. We know that this angle A down here is 90. So how can we figure out this B right here? All of it has to add together to make what? Okay, so put a little note for yourself. It has to add to equal 180, right? Inside a triangle. So that means if we know the 78 and we know the 90, we can figure out this last B. 11 point what? 95? Okay, and then we can put our answer over here. 11.95. These are degrees, actually, right? So really, all you had to do was remember this very first thing, right? If they tell you what cosine or sine of something is, then you can do the other thing. Okay, so we're gonna sine of B. You already know this. Fill this in right now from your secret code. You remember? What's this? Shh. Right. Switchy, 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 switchy. Cosine. Cosine what? Is it? Look at the picture. What are you not allowed to use?
I say C.
It's C. And if you actually wanted a number, you actually have the number up here. It says cosine C is that. So you could actually even put the number if they wanted a number. Okay. So okay. So the A level ones, we have like 9 minutes, so stop talking. So if you take a look at this, don't write anything yet. Put your pencil down. So when you get a problem, what puts you in the A level is that you have not just by rote memorization been like, oh, I'm missing the side, opposite adjacent. The A level makes you look at a picture and decide what you have to find first, and then actually find some stuff. So if you look at these two pictures, and you don't have to pick up your pencil right now, I'll talk through them, and then you can write down the important stuff after. Okay? If you're trying to write while I am doing it, it's going to be kind of confusing. Okay, so if I want to find the area of a triangle, you first need to know the area of a triangle formula from 6th grade. Let's ask our middle school student if they know the area of a triangle formula. Do you remember? A equals 1/2 base times height. Does that ring a bell now? Yeah. Okay. Okay. So that's the area. If I want to find perimeter, how do I find perimeter? Add up all the sides. I hope some of you want the A level.
A level. This A level.
Okay. So these are two things you have to know. If somebody asks for the area, you have to know area equals 1/2 base times height. If they ask for perimeter, you have to know you have to add up all the sides. Now that tells you what you need to get in order to answer these questions. So you don't have to just look at the picture and solve for every single thing, because they're not going to put an X and weird stuff on the sides. They're just going to give you the picture, and you got to know what you need to know. So let's just use some common sense. I'm not doing these problems. I'm going to talk you through them. So look at this first picture. Looky, looky. This picture here. If I wanted to find the area of it, there are two things I need. I need the base and the height. If I look at this picture here, do I have the base and the height of this triangle? I don't have the base. So the base is right here. I would have to find that. Do I have the height though? Yes. So all I would have to do is one little trig ratio to find this b, right? And then I'd be able to do 1/2 base times height and get the area. So that is like one simple trig problem. That's it, right? Okay, I would circle this angle. I'd be using my opposite and my adjacent. I would use tangent. I would get this value, and then I could plug it in my formula. Yeah. If I wanted perimeter, if I was asked to find the perimeter of that, you tell me I need all the sides. How many sides are there on that? 3. So I have one of them. I would still need to find this one, but what else would I need to find? I would have to do this one too. So that would mean I would have to do 2 trig problems in order to find the perimeter, because I have to do this side, and then I have to do another trig problem to get that side, and then I can add all 3 of them up to get my perimeter. Okay? So for this problem, area is going to be the easier one to go, right? If I had an option of picking something, right? Yeah. For that problem. Now let's look at this picture, because you don't have to do the exact same thing every single time. So look at this picture. If I wanted to find the area, I need the base and the height, right? Do I have the base of this? No. And do you see how this is made from 2 right triangles? That means I'm allowed to use just this triangle over here if I want. I'm allowed to use just this triangle over here if I want. I'm not allowed to use the big triangle, because the big triangle is not a right triangle, right? But you have 2 little ones to deal with, so you'd be able to do it. So if I wanted to find the base, I have the 5, right? I would just need to know this piece right here, right? So I could use like this triangle here, and I could use to find this little X or whatever I want to call him, right? And then I'd be able to get this base, right? Do I have the height of this triangle? Height has to be straight up. So do I have the height in this picture? What color is the height in this picture? It's this green line right here, right? I don't have it. So I would have to do another trig ratio to find this height, right? Because then I could have my whole base and my height, and I could do my formula of 1/2 base times height, right? So in order to find area for this one, I would have to do trig twice to get 2 parts and then plug them in, right? Okay, what if instead I said find the perimeter of this guy? Perimeter is all the sides around the outside, right? So do I have all the sides? Thinking about perimeter, if I start here, I have that side, 12, right? Point something. I have the 18. I have some of the bottom, but I still would need this piece here, right? Do I need this piece for perimeter? No. So for this one, if I had to find perimeter, I literally just have to do one itty bitty trig problem and find this piece right here, and then I could add up all my sides. Okay? You see how you gotta like look what you have, what you need, and then just find right triangles in it and do the trig pieces to find the pieces you need. Nobody says I have to find every single piece of this triangle, right? I just need the pieces I need for area or perimeter, whatever they're asking me to find. Make sense? Let's look at the very last one, just super quick. Oh, that one's easy, because that one you could just draw the picture. What would you do for this last guy, though? When you see this, how can you start this off? What can you put in? What? Second sign, right? Can't I put in second sign and then put that junk in 0.576? Because then that's going to give me this angle measure right here on X, right? And then I'll be able to get all the rest of the stuff. Okay? Okay, so can you do your test tomorrow? I believe in you.